any substances, if it is occupies a space and have a mass, then it is said to be a matter. Thus, mixtures will be broadly classified into homogeneous mixtures and heterogeneous mixtures. The different atoms, if it is combined in a fixed ratio, then it is said to be a compound. The maximum number of electrons that can accommodate in the K shell is equal to 2. Hello everyone, welcome you all. This is me Purnima at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last session, we were enjoying the whole session by learning what is the chemistry and how the chemistry has become a part of our life and what will be the branches of chemistry and how the chemistry is so important to our daily life we have understood, right? So, we have understood what is chemistry and also we have understood the importance of chemistry and also we have understood the branches of chemistry. Today, let us move on to the next step, okay? That is, we are going to understand more about the matter, okay? I hope that everyone have heard about the word matter. If you see this picture, can anyone say that what is a matter? If you clearly see this picture, you can say that there are so many living things and the non-living things are there, right? Any things it may be, if it is occupies a space and have a mass, then it is said to be matter. What is a matter? Anything which occupies space and have a mass. Here, you can see that a person who sits on a table and he was working in the laptop. And if you see that surrounding, you can see that cat is there, a plant is there, window is there, cloud, chair, coffee, everything will be there. So that include both the living things and the non-living things. All these things, they have a definite shape, right? So when it is placed in a table, each object or each material, it occupies a space and have a mass. If any substances, if it is occupies a space and have a mass, then it is said to be a matter. So this is a simple definition will tell us that all the surrounding, in our surrounding, almost all the different materials which is present is made up of a matter only. Almost all the substances which exist in our surrounding is made up of a matter. Okay? And the study of the matter which comes under the chemistry. Let's see what are all the classifications. Okay? Later we'll move on to the states. Usually, the matter can be broadly classified into two types. Okay? First one is a physical classification and second one is a chemical classification. So, the matter can be broadly classified into two types. Which are those? A physical classification and again chemical classification. If I talk about the physical classification, which comes under the physical states of the matter. So, what are the physical states you can see in the matter? There are three main states will be there. Which are those? A solid, a liquid and a gases. So, these are the physical classifications of the matter. So, how do you say it is a solid? How do you say that any object is a solid? When all the particles in the solids are tightly arranged, so there is no much freedom in a constant particles in a solid. The particles are tightly arranged. There is no much spaces between the constant particle. That is why all the solids, they have a definite shape and a definite volume. For example, I am having a pen, okay? So it has a definite shape, right? It has a definite volume, right? So that expressed in terms of mass also. So any substances, it has a definite shape and a definite volume, then we say it is a solid. Remember, in the solid, the particles are so tightly arranged without any freedom. Coming into the second physical state, that is the liquid. In case of liquid, we all know that the particles are somewhat freely arranged. That is why the liquids, they have a definite volume but not the shape. But it takes the shape of the container. That is why when you fill the water to the water bottle, it takes the shape of the water bottle. When you pour the water to the bucket, it takes the shape of the bucket. That says that almost all the liquid, they have a definite volume but not the shape. It takes the shape of the container. Coming into the last physical state is a gaseous state. In a gaseous state, if you see this figure, you can only tell that the particles are so free. There is no restriction for the constant particles. So they are moving very freely. That is why almost all the gases, it does not have a definite shape and not the volume. But remember, it takes the shape of the container and it takes the volume of the container. So these three states of the matter which comes under the physical classifications of the matter. Or we can say that these are the physical states of the matter. Which are those? A solid, liquid and a gases. So coming into the chemical classification, okay? Coming into the chemical classification, again, the matter can be broadly classified into two types. Do you know which are those? First one is a pure substances and second one is a mixtures, okay? Based upon the chemical composition. Based upon the chemical Based upon the chemical composition, we can classify the matter into two types. Which are those? A pure substances and a mixture. Again, these pure substances will be broadly classified into two types. First one is the element and second one is the compound. These are the sub-branches of the pure substances. Coming into the mixtures. Okay. Again, these mixtures will be broadly classified into homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures and heterogeneous mixtures. So, how do we classify the matter? We can classify the matter into two types. So, one is based upon the physical state, other is based upon the chemical composition. So, if we classify the matter based upon the physical state, there are three types, okay? Which are those? Solid, liquid and gases. So, when I classify this matter based upon the chemical classification, we can say that matter are of two types. Which are those? A pure substances and a mixtures. And which are the pure substances? We'll learn now. When I say it is a pure substances, I think in your home you would have seen that the packet of milk that shows that a pure milk. Simultaneously, you would have seen with a ghee packet also. A pure ghee will be written on the packet of the ghee, right? So, what are all these substances then? A pure substances are the substances which consists of only one type of particle. Which consists of what? Only one type of particle. Pure substances are the substances which consists of only one type of particle. Then we say it is a pure substances. The best example you can give you is a gold. If you take the gold chain or the gold bangle, all the gold materials is made up of what? Gold atom, right? It is made up of gold atom. Similarly, if you take the iron nail, it is made up of iron atom, right? Similarly, if you take the ghee, which is made up of a ghee only, and also, which is made up of only one type of particle, we can say, okay? Similarly, if you take the copper wire, which is made up of a copper only. Any substances, if it is made up of a single type of particle, then we say such substances are belonging to the pure substances. You can list out the pure substances which we used in our daily life, like a gold, iron nail, ghee, pure milk are the examples for this pure substances. Again, we come to know this, where these pure substances will be broadly classified into two types. Which are those? Elements and a compound. So let's see what is an element. Remember, element are nothing but which consists of only one type of atom. Elements are made up of only one type of atom. Example, here I have taken the example of the helium. So the element which is made up of only one type of atom. So this is an element, okay? Element which is made up of only one type of atom. Then we say it is an element. If two or more atoms are combined, the atoms of the similar type, we can say that if it is combined, they forms a molecule. They forms a molecule. The atoms of the similar type, like hydrogen, hydrogen atom, oxygen, oxygen atom, if it is combined, then it forms a molecule. Coming into the compound, how does it form? The two or more atoms, the different atoms, if it is combined in a fixed ratio, then it is said to be a compound. For example, if you take the example of water, we know that hydrogens, there are two hydrogen atom will be there, but only one oxygen atom will be there. So the two hydrogen atom, always it combines with one oxygen atom in a fixed proportion. Then only we can say it is a compound. Compounds are the substances which is formed by combinations of two or more different elements, okay? But they are in a fixed ratio. Then it is said to be compound. The first other example I can give you is ammonia, that is NH3, where the nitrogen is only 1 and hydrogen are 3. Even though they are two different atoms, they are combined, but they are combined in a fixed proportion and forming a compound. This is how simply we can define the elements, molecule, and also with the compound. So what are all the elements? Elements are made up of what? Only one type of atom. You can write hydrogen atom, okay, it's an element which is made up of hydrogen atom only. You can take the example of the helium atom. You can take the example of the nitrogen. Okay, it is an element which is made up of a nitrogen atom only. You can list out the number of elements which you already learned in your previous classes, which is belonging to the pure substances. Okay, the elements are the one which consists of what? Only one type of atom. If two or more atoms are combined in a fixed ratio, then it is said to be compound. If the atoms of the similar type, say hydrogen, hydrogen, say oxygen, oxygen, say nitrogen, nitrogen, if the atoms of the same element, if it is combined, then we say it is a molecule. Then we say it is a molecule. We cannot say it is an element. We say by the word called as molecule. Okay, atoms of the same element, they combine and forms a molecule. Hope you all understood with the definitions of the element, molecule, and also with the compound. Now, let us move on to the other classification of the matter, that is mixtures. Till now, we have studied about the pure substances. Let us study the other part, that is a mixtures. Do you know what is a mixture? Mixtures are nothing but a substances which is obtained by combining the two or more different elements. If two or more different elements are combined in any other proportion, then we say it is a mixture. Again, these mixtures are of two types, that is homogeneous mixtures and heterogeneous mixtures. What is homogeneous mixture? For example, to explain this, I'll take the example of the glass of water. Okay, imagine you have a glass of water. This is a water. To this, you are going to add a tablespoon of sugar or a salt. You are going to add a tablespoon of sugar and salt. If you add sugar to this glass of water, what will happen if you stir that sugar? Sugar will obviously, it will dissolve and forms a sugar solution. Forms what? Sugar solution. Or if you add salt, it will dissolve in the water and forms a salt solution, right? Now, my question is, whether can you separate this salt and water by physical method? Can you separate it out? No, it is not possible. Do you know why it is not possible? Because when you add a sugar or a salt to water, the constant particles are uniformly distributed throughout the system, right? The particles are uniformly distributed. There is no separation. You cannot separate the constant particle like a sugar and a water. That is why after the sugar solution or after the salt solution, once it forms, we cannot separate it out. So that shows that a homogeneous mixture is a mixture, but the constant particles are uniformly distributed throughout the entire system. So then only we can say it is a homogeneous mixture. When we can say that it is a homogeneous mixture? Only when the constant particles are distributed uniformly throughout the system. Okay. Then only we can say it is a homogeneous mixture. Example is salt and water, or sugar and water, or lemon and water. Lemon juice and water is an example for the homogeneous mixture. Coming into the heterogeneous mixture. The name itself shows that it is a hetero, which means that different. The same example I can take you. Take a glass of water. Okay. This is a water you are taking. To this, you are going to add a oil. Imagine you are going to add a tablespoon of oil to the glass of water. What will happen? Do you know? So, the oil and water, it never mix at all. It always form a separate layer, right? It always form a separate layer and it never mix. So, this shows that the constant particle in this mixture, they are not uniform at all. They are not in a uniform, which means that they are not uniformly distributed. We can separate this oil and water by a physical method. Hence, it is said to be heterogeneous mixture. Hetero means different. Okay. The constant particle, if you see this picture, you can clearly understood that the constant particles, they are not uniformly distributed. Hence, it is said to be heterogeneous mixture. So, this is how again the mixtures will be broadly classified into homogeneous and a heterogeneous. Okay. I hope you all this concept which will be more understanding for you. Till that, what we have studied about the matter, we have studied about the definition and we studied about the classification, that is a physical classification on one hand, and on the other hand we studied about the chemical classification based upon the chemical composition. All this concept you already learned in your 10th standard, right? But the More advanced format of this concept you're going to learn in the first PUC, the first chapter, the basic concepts of chemistry. Under that, you're going to learn more about the matter. What we have studied till now, you're going to learn more about the matter in the first PUC, the first chapter, basic concepts of matter. Okay, coming into the next concept, that is a structure of matter. Why, ma'am, after this matter, why the structure of atom is so important? After learning that in the pure substances, we have understood that again there are two type elements and the compound, right? If somebody asks you what is an atom, what you will say? Atoms are the smallest units of matter. Atoms are the smallest units of matter, right? If somebody says that what is the structure of the atom, what you will say? It is in a spherical shape and it consists of what? Three basic particles. Which are those? A proton and the neutron, which is present in the nucleus, and electrons will be present in the outside of the nucleus, right? So these are the three main basic particles which is present in that atom. What is the shape of the atom? It is a spherical shape which consists of what? Which consists of the nucleus. Inside the nucleus, what it is present? A proton and a neutron. Do you know what is the charge for the proton? Can you recall it? What is the charge? Yes, it is a positive charge. Protons are positively charged. What is the charge for the neutron? There is no charge for the neutron. Okay. What is the charge for the electron? Very good. It is a negative. So, electrons are negatively charged. Okay. Remember, if I say that atoms are the smallest units of the matter. Okay. So, this is a basic structure of atom which consists of three basic particles, that is a nucleus and also electron. Remember, inside the nucleus, proton and neutrons are present. Outside of this nucleus, electrons are revolving in a circular path. Coming into the number of shells in an atom. I think in your 9th standard, you have studied about the structure of atom, right? Under that, you have studied about the different theories which is brought about by the different scientists. And also, I hope that you have learned about the Bohr model of an atom. He is only the scientist. He gave this a structure of the atom in the form of spherical shape. And also, he explained that atom which consists of a positively charged nucleus. He says that atom which consists of positively charged nucleus. Who says this? It was said by the Bohr. Okay. According to the Bohr model, we can say that atom will be consist of positively charged nucleus. Why it is said to be positively charged nucleus? Because inside this nucleus, protons and neutrons are present. Since protons has a charge, whereas the neutron does not have a charge, hence it is said to be positively charged nucleus. After this, he says that after this nucleus, there are many number of shells will be present, right? They are also called by the name called energy levels or a orbit or a shells. They are named as a shells, orbit or the energy level. And also he gave the naming for this, that is K, L, M and N shell. So these are the different orbitals or the shells which is present within an atom, right? And also he explained that how to fill the electron into these shells. How do we fill? We have a formula, right? Can you recall it? What is the formula to fill the maximum number of electron in each shells? That is very good. 2n square. So this is a formula which we use to fill the number of electrons in the each shell. What does it represents n? What is the N here? N is nothing but a number of shells. N is nothing but a number of shells. Suppose, okay, if N is equal to 1, imagine N is equal to 1. What happens to the formula? Then 2 into 1 square, it will become 2 only. So that the maximum number of electron that can accommodate in the K shell is equal to 2. Is equal to 2. Suppose if N is equal to 2, imagine the formula will become 2 into 2 square. Obviously it become 8. So that the maximum number of electron that can accommodate in the L shell was equal to 8, not more than 8. Okay. Similarly, if you place N is equal to 3, then it become 2 into 3 square, it become 18. It become how much? 18. It become 18. Similarly, if you place N is equal to 4, then it become 2 into 4 square, it become 32. Right? That shows that the maximum number of electron that can accommodate in the N shell is 32, not more than 32. So these are some of the basic concepts that we have already learned in our previous classes, right? So in your 9th standard, I hope that you all studied with all these concepts from the Bohr model. Remember, Bohr was a scientist. He is the first scientist. He gave the spherical shape of the matter and he explained that spherical shape of the atom, not a matter. And he explained that within the atom, there is a positively charged sphere will be there and it consists of a number of shells known as orbital, and for each orbital, he fills the maximum number of electron by using this formula. And remember, don't forget this values for the K, L, M and N shell. This is an idea which gives that to which shell we have to fill the maximum number of electrons. So this is the only thing which we followed till now to fill the number of electrons in the each shell which is given by the Bohr model. Hope you all understood with this concept. We'll move on to the symbol of the element. After knowing the number of shells and how to fill the number of electrons in the each shell, we need to know the how to represent the elements. How we represent the element? Usually it is represented by the symbol called as X. Okay, X is a general symbol for the elements. Okay. If you see this picture, I have written an X, but on the upper side I have written a letter A. And below I have written the letter Z. Here, the A represents mass number. Have you heard about it? What is a mass number? How do we calculate the mass number? Mass number, which is very simple, which is obtained by counting the number of protons and the number of neutrons, which is obtained by counting a number of protons and the number of neutrons inside the atom that gives the information about the mass number. Remember, this mass number always we used to represent by the symbol called as A. Coming into the atomic number. Atomic number which is obtained by counting the number of proton. Only if you count the proton, then only we can say it is a atomic mass. And number of proton which is also sometimes equal to the number of electron. Or if you count the number of electron or if you count number of proton, that is nothing but a atomic number. And remember, we used to represent this atomic number in terms of a symbol called as Z. So don't forget the symbol for representing the atomic number and also for representing the mass number. Mass number can be written or represented by the symbol called as A, whereas atomic number it will be represented by the symbol called as Z. Remember, atomic number is nothing but a number of proton inside the atom, whereas a mass number which is nothing but a number of proton plus number of neutron. present inside the nucleus of an atom. And remember, X is a general symbol that used to represent the elements. In place of X, you can place any other element symbol. Next is valency. After knowing the representations of the element with the atomic number and also with the mass number, we need to understand what is a valency. Do you know what is valency? Valency is a number of electron which is present in the outermost shell of an atom. What is the valency? It is a number of electron which is present in the outermost shell of an atom. How do you say that the valency for an atom is 1 or 2 or 3? Let's see. Okay. Here, I have taken the example of the carbon atom. Okay. Here, I have considered the example of the carbon atom which consists of the nucleus. Okay. Here, for the carbon, atomic number is 6. Atomic number of carbon is 6. Okay. So, how do you fill this electron into the each shell? As we all know that we have to fill this electron from the K shell to the N shell, right? We know that K shell can accommodate only 2, whereas N shell can accommodate only 8, not more than 8. Whereas M shell can accommodate 18, whereas N shell can accommodate 32. So that we have to start filling the electron from the K shell. First I will write the K shell and I have filled the 2 electron. Why I have to fill only 2 electron? Because the K shell can accommodate only the 2 electron. Coming into the next one, this is a K shell. Next is L shell. So how many electrons are remaining? Out of 2, so the 4 electrons are remaining. So I will fill these 4 electrons in the next L shell because L shell can accommodate 8 electrons. So how many shells become for the carbon now? Only 2 shells, right? Don't write M and again N. Okay. So how many electrons which you can fill in each shell, that depends upon the number of shells. Okay. And we have to fill this electron according to the Bohr model. And also, after filling this, we come to know that for the carbon, we have only 2 shells. So, which is the outermost shell here? L will be the outermost shell, right? So, how many electrons are present in the outermost shell? Can you easily count? 1, 2, 3 and 4. So, there are 4 electrons which is present in the outermost shell. Hence, these 4 electrons which are responsible for the valency of the carbon. So that the valency of the carbon is 4. The valency of the carbon is 4 because there are 4 electrons which is present in the outermost shell of the carbon, that is in the L shell. Coming into the other example, that is nitrogen. The atomic number for the nitrogen is 7. Okay, atomic number for the nitrogen is 7. How do we fill the electron? Same as we followed in a carbon. We have to fill the first 2 electron in the K shell, okay, followed by the L, M, N. Because the K shell can accommodate only 2, not more than 2, whereas L shell can accommodate 8. So, we are filling the remaining 5 electron to the L shell. Okay. If you count the number of shells, for the nitrogen, there are only 2 shells, right? In these 2 shells, the last shell is a L shell, which consists of 5 electron. Which consists of what? 5 electron. This 5 electron, which is present in the outermost shell, hence the valency of the nitrogen will be 5. Hence the valency will be 5. Why it is a 5? Because the valency is nothing but a number of electrons which is present in a outermost shell of an atom. It is nothing but a number of electrons which is present in a outermost shell of an atom. Hope you all understood with the valency topic. Coming into the composition of the few elements, few atoms of some first 18 elements I have listed out. So, from this, we can clearly understood that how we are going to represent the element And how we are going to count the number of proton, neutrons and electron, and how do we represent this number of proton and neutron in the different subshells, and what will be the valency? Let us understand for a first 18 element. So, if you learn first 20 elements with the atomic symbol, with the symbol and the atomic number, it's very easy to understand the chemistry concepts. Okay, at least from 1 to 20, you must know the symbol and you must know the atomic number. So, the first element in the periodic table is hydrogen, and it having the atomic number 1. Okay, so how many number of proton will be there? Only 1, because atomic number is 1. There will be a neutron will be 1. And how do we represent the in terms of KLM shells? We used to fill the electron from the K shell. We have to fill the electron from the K shell, so that the K shell will be outermost shell for the hydrogen. Hence the valency will be 1. Valency will become 1. Okay. If you write in form of structure also, it's very useful. Coming into the helium, there is a second element which is having the symbol called as He. Remember, in chemistry, the first letter for representing the element must be in a capital letter. Okay, and the second letter should be in a small letter. The atomic number for the helium is 2. Okay, the number of proton is 2 and number of electron, which is equal to number of proton, and number of neutrons are 2. Okay, how do we represent here? Atomic number should be filled first to the K shell. So, the K shell can accommodate only 2 electrons. So, the K shell will be outermost shell. Hence, the valency will be 0. Why the valency is 0? Because we have already learned that the K shell can accommodate only 2, whereas L shell 8, whereas N shell is 18 and N shell will be 32. If these electrons are satisfied to the each shell, okay, that will attain the stable electronic configuration. If there is no satisfaction to the stable electronic configuration like 2, 8, 18 and 32, then it will become a valency. Okay, so here in the helium, the 2 electrons which is present in the K shell, it will satisfy to the K shell because the maximum number of electrons which we already filled, so it attained the stable electronic configuration, hence the valency will be 0. Hope you understood. And next element is the lithium, and their atomic number is 3. Atomic number here 3 means number of proton will be 3. Number of proton is 3 means number of electron will be 3, and also number of electron will be 4, and also number of neutron will be 3 here. So that we used to represent this in the form of KLM shell. So we have to fill this 2 electrons for the K shell and next one to the L shell. The L shell can accommodate how many electrons? 8 electrons. So it is not satisfied, only 1 electron is there. So it belongs to the outermost shell, hence the valency will be 1. This is how, by attaining the stable electronic configurations, the electrons or the entire atom will be attain the stable configuration also. So don't think that if you put the 2 for the K shell, it is a valency will be 2. It will be 0 because it attains the stable electronic configuration. If number of electrons it does not satisfy the stable electronic configuration, then it become a valency. Okay. Next, beryllium 4. Atomic number will be 4, number of proton will be 4, number of neutron will be 4, 4 plus 1, the number of electron will be 5. So, how do you fill? So, here the 2 plus 2 electrons will be filled to the K shell and L shell. L shell can accommodate only 8 electrons, but here we have a 2, hence the valency will be 2. Whereas in boron, we can use to represent the boron in the capital B form and the valency will be 5. Again, the number of proton is 5. Proton plus neutron, which is equal to electron, that is here 6. So, it is 5 again. We fill in the K shell and M shell, so that valency will be 3 because in the L shell it has a 3 valence electron. Coming into the carbon and the nitrogen, just now we have discussed that the valency of the carbon and nitrogen will be 4 and 3. Okay. Coming into the oxygen. So, the oxygen valency will be 0. Okay. The oxygen valency will be 0 and also it has a oxygen will be used to represent the symbol called as O, and also atomic number will be 8, number of proton will be 8, and also number of neutron will be 8. And how do we distribute this electron into the each shell will matters, and hence the valency will become 2. So till neon, if you learn, or till to the first 20 elements, if you learn, it's better for you to understand this, how we represent the element with their symbol, with the atomic number, how we can count number of proton and number of neutron, and how do we distribute this electron into the number of shells, and how do we count the number of valency also. It is very important in the chemistry. Hope you all understood with this concept. I think this concepts also you have understood in your 9th standard, or you have learnt in a 9th standard. Again, from the structure of atom till here, what we have learned, this concepts will also come in your first PUC classes. Okay, in the first PUC, the chapter 2, that is all about the structure of atom. So you are learning about more about the structure of atom in this chapter. Under that, you are going to learn more about the structure of atom in detail. Okay, this is all about the today's session. Hope you all understood with this session. And at lastly, I like to say that think like a proton and stay positive. Thank you.